lava the islands come. From food comes growth. This shows that there is change throughout the whole world. People change, but with matter, there is a whole other process for its state to change. The documentary that you're about to watch is from the series called Change. It shows the life of a science professor from NYU, whose specialty is on matter. The documentary is based on the life of NYU professor Mary Johnson. Dr. Johnson has a PhD of science and is a great intellectual. She has been imparting classes at NYU or New York University since the age of 28 and lives a very healthy life in the suburbs of New York City with her cat. The doctor isn't a very social person. She's more of an introvert. She likes to read, to sleep, and is very fond of discovery. Her life is based on matter. She likes to see what takes up space, either in the world or in her life. The changes of state and matter is what she adores, because she likes to see how things change. She's not very adapted to change, but that is not for us to judge. Now, we will begin with the documentary, and I would like for you to please observe and watch how everything changes.
Morning world.
Marie doesn't wake up at time and finds out that instead of 5 more minutes in bed, 30 minutes passed and she's really late for class.
I'm late, I need coffee.
Good morning, class.
Good morning.
Everyone knows by the look of the professor that she isn't prepared for class. She changes her appearance by adding topics that don't make sense to what she's saying. And as a professor of matter, she's supposed to know everything.
Remember about last class?
We're explaining and giving an introduction of the changes of state.
Do you know anything about this topic?
From high school, I remember mainly freezing and melting, and basically the cycle of water with evaporation, condensation, and water.
Dr. Johnson tries to improvise the class by asking what do they know about the topic, but only one person responds, and by the time the class ends, and she feels really frustrated about the incident because they didn't got to do anything. When she arrives home, she goes straight to her computer to plan the class, and so that she can compensate for what had happened. Now, the professor arrives at her house and is making the whole class
You all know matter is anything that takes up space and energy is related to the work or cause change. The only way we can change matter is by changing its state, which basically means it uses energy. Solar panels use the sun's rays to create renewable energy, which means that you don't lose energy throughout the process. As well, when you change the state of matter, you don't lose energy. The energy might increase in cases like when you go from a solid to liquid, but when you change from liquids to solid, the level of the thermal energy will decrease because thermal is of hot.
To cool your drinks, you always have the alternative to add ice cubes to it, or even freeze it. But what if you can do all the changes of the state of matter just with water? Well, here's the process. First of all, you have the ice cube tray, which you will fill with water. The water, as explained before, has less thermal energy because by freezing it to create ice cubes, you decrease its amount of thermal energy, which is the definition of the process of freezing. How the liquid in the moment is at its freezing point, the particles of the ice are moving more slowly, which means that they take certain positions.
Now, you get the excellent idea to make a cup of coffee just to wake yourself up and realize that you ran out of water, which is hypothetical, by the way. But anyways, you take those ice cubes and melt it in a pan to create water. But remember, the water has a melting point, which is 0 degrees Celsius, same as freezing.
The ice cubes went from solid to liquid, but something that is strange and not very known is that the melting point of water is a characteristic, which means when chemists want to analyze other materials, they try to look for their melting point. I saw that the ice cubes that are in the pan, their particles vibrate so fast that they don't have certain positions, which is the opposite of freezing.
When the ice cubes are melted, you have your water. Then you will like to boil it to get it even hotter, which means that the coffee will be made faster. The boiling of water is one of the two main types of evaporation. It's the one that takes both below and at the surface of the liquid. The boiling point of the water is the temperature in which that liquid boils. The other type of evaporation is evaporation, which is the type that takes place only on the surface of the liquid. Then you realize suddenly that the water is way too hot, so you decrease the amount of fire on the stove. You let the water sit and you wait. Then you see these tiny droplets of water under the lid, which is a sign of condensation. Condensation is when the gas is so loose that it forms a liquid, which are the droplets on the lid.
Sublimation, which most of the people doesn't know exists, is the change of state that occurs when a solid passes to gas without going to liquid. A known example of this change is dry ice, which is a solid carbon dioxide and creates the smoky effect when added to hot water. This is it for today.
Did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation. This is only demonstrated by particular materials, such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it would turn straight into a gaseous carbon dioxide. Liquid carbon dioxide does exist, but only occurs under very high pressures.
Have you ever wondered why ice turns into puddles of water on a sweltering day? Keep watching and you'll find out. On Earth, materials exist in one of three main states of matter: solid, liquid, or gas. Materials can change between these states. When a state change occurs, a substance's property will also change, maybe not too surprising. However, if the state change is reversed, the substance will recover the properties it had to begin with. Neat. Matter can transition between the three states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangements of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form. These four words describe changes in state. Do you know which word refers to which change? Pause the video, fill in the gaps, and click play when you're ready. Did you get them right? Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization. The opposite of these vaporization processes is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day. Those water droplets on the outsides, or the dew on the grass in the morning, or the steamed up mirror after a hot bath, even the clouds in the sky, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now let's think about the transitions between solids and liquids, so melting and freezing. Think of the Arctic sea ice. In the summer, when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice's water molecules and the ice starts to melt. The solid ice becomes liquid water. But in the winter, the air temperatures are colder, and so seawater freezes, and the ice starts to form again. There is less heat energy within the ice, and so more bonds can form, holding it together as solid ice. So far, so good. But did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation. This is only demonstrated by particular materials such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it will turn straight into gaseous carbon dioxide. Liquid carbon dioxide does exist, but it only occurs under very high pressures. Similarly, gases can turn straight into solids when cooled. This is called deposition. Let's check out how much you remember about the changes of state. Pause the video and fill in the blanks. Did you remember them all? Our final thing to discover is that when a material changes states, the mass stays the same. The density changes, so the mass per unit volume, but the mass does not change. Our glass of nice cold Coke weighs the same whether the ice is solid or when the ice has melted. So there we have the changes of state. Just remember that the mass stays the same whatever the state.
If you liked the video,
Thank you.
did you guys enjoy the class?
Yes.
In the last episode, we got to see the changes of matter. We hope that all of our viewers enjoyed and appreciated how the changes in state can be very useful at any moment in our lives, every day. With this episode, we aim that everyone learned with the teachings of Professor Mary Johnson, PhD of Science. We expect this because the series are based on gaining new knowledge or information, so in the future, the next generation takes the world by storm. We want to see change, either good or bad. It will always help to improve our future.